In this video, we're going to talk about example 11.6, the central limit theorem in action. So as we go through this example, it starts off by saying in March 2009, the current population survey contacted 97,066 households. So what we're seeing here in this first figure is the distribution of earned income in a population of 75,310 households. So this is the actual distribution as we plotted every single one of those households and how much that household earns. This is what the distribution looks like. And it kind of makes sense that the distribution is really skewed. We've talked about in class how income distributions are always going to be skewed because some people make considerably larger amounts of money. In fact, the book says that in this particular example, they topped off this graph at $400,000. But we know that there are many households that earn millions of dollars. It just, if we were to have the scale go all the way out to the millions of dollars that some people earn, we would lose all of this information down here. It would become so small you really couldn't see it. So since we know out there are just going to be some random outliers, we didn't include that here in the graph. And also for the scale of the graph, the numbers of those, they would be so small that the percentages of them are so small they really wouldn't show up anyway. So again, this is the population distribution. This is the actual dollars earned for all of these different households graphed on this chart. Now, on the other hand, we want to talk about what happens if we take samples of 100 households, and we're going to take 500 of those samples. So we're going to sample 100 households, find out how much they earn, find the average. Take another 100 households, find out how much each of them earn, take the average. Take another 100 households, find out how much each one earns, take the average. And we're going to do that 500 times. And what we're going to graph here is the mean of all of those 500 samples. So we're not actually graphing the actual income of all of the people in those samples. We're graphing the means of those samples. So this here is a sampling distribution of the sample means, or we just kind of call that the sampling distribution for short. So this sampling distribution shows that what the central limit theorem says is true. That when we do a sampling, even if our original population, back to this original graph, which is clearly not normal, no matter how crazy this graph is, and if you watched the Khan Academy videos on this topic, you'll see he did some really crazy examples of populations that are very not normal. Once you do all of these samples, and sample, take an average, sample, take a mean, sample, take a mean, sample, take a mean, and plot all of those means, the means will approximate a normal distribution. And the reason for that is because we are taking a very large sample of 100 households. We talked about the law of large numbers and how the larger the sample is, the more closely the mean of that sample is going to be the true theoretical mean. And because of that, the sampling distribution is going to be normal because we'll have most of the values will be right around the actual mean. Some will be a little higher, some will be a little lower. So it's normal because it's going to be fairly symmetrical in that way. And it's also going to be very narrow because we're taking large samples, which means that each sample mean is going to be pretty close to the real actual mean. So this graph here just puts both of them on top of each other with the same exact scale so that you can actually see how these two relate to each other. Again, this top graph is the population distribution of all the actual incomes for those 96,000 households, whereas this bottom graph is the sampling distribution, 500 samples of 100 people and the means of all of those samples. And then the fact that the sampling distribution is a normal curve gives us a lot of good information and is something that's valuable, that we're going to be able to do a lot of calculations based on that and statistical estimations. So this picture here is just a blown up version of that sampling distribution so that you can more clearly see that the shape is approximately normal.